Hi there, Prof here. Welcome to C++ 101. If you watched my previous tutorials, then I believe you have installed the Dev C++ IDE or any IDE of your choice. So today we are going to write our first program in C++, and all we will do with this program is to display Hello World on the screen, after which we will look at some fundamentals that you need to write even the very basic C++ application. Okay, so let's get started. Okay, so in here is a basic C++ program, and all it does is write this text hello world to the screen. It's a form of tradition that we do for beginner programmers, but never mind, we are going to do something awesome in later episodes. Okay, so let's go ahead and run this program, and you can see here we have this boring console, and all we have in there is hello world. Okay, if you remember from my previous episode, I said that a program or instruction written in a high level language is called a source code. So what you see here is a source code written in C++ or a C++ source code. Now, we also said that C++ is a high-level language, and the way we defined a high-level language is the fact that the syntax or the things, the codes written in C++ have words that are borrowed from natural languages. And you can see over here we have return, which is an English word, we have main, we have using, we have a stream, we have include. So these are the things that makes a programming language a high level language. The syntax or the code that we write looks so close to a natural language, and it doesn't always have to be English, or it could be any other language so far as the compiler is able to understand. If you remember, we said that when you write a program in a natural language, the the computer cannot execute that program directly. So for instance, if these things here, the computer has no idea what they can do. Okay, this is mainly to make you, the programmer, your work very easy, because this is more familiar to you, the human. Remember, we said that the only language the machine or the computer can speak is the machine language, and it's strictly zeros and ones. So in fact, the computer doesn't even know whatever is happening here. Then we say that in the case of assembly language, when we write the codes in mnemonics, then we use a program called an assembler to translate the mnemonics into machine language equivalent. Good. And in my previous tutorials, I said that for the case of C++ and high level languages, we have either an interpreter or a compiler. Now, C++ is a compiled language, so we won't use an interpreter here. We need a compiler. So what happens is that anytime I hit compile and run, the compiler, which is also part of this IDE, remember, integrated development environment. So all those programs are bundled together with this program here. So all I have to do is to click on this and everything is done. Well, so when I click on compile, what happens is that the compiler then translates this source code, which is in a high level language, to machine language equivalent. So if we go to the file system and look around, so you can see that my source code, I named the file helloworld.cpp. Okay, and you can see that that is what we have here. Okay, that is what we have here. Now remember, we also said that source codes, or the file that contains our source code, is called a source file. So this is a typical example of a C++ source file, and the reason it says a C++ source file is because of this extension .cpp, and I talked about all these things in my previous episode. All right, so we created .cpp. So where is this hello world.exe coming from? Okay, good. Now let me do a little change here. which I will explain later, and compile again. Now, one thing you would know is that anytime you make any changes in your program, you have to recompile for the changes to affect the machine language or the executable. Okay, so now if we go back, look at this. If I double click it, that is the program. It begins to execute. Now let's try and open this in Notepad and see what happens. So I'm going to drag this into Notepad. Spoiler alert, we are going to get something we never coded. Okay, boom, that is it. So if you remember ever typing any of these gibberish in the code, yeah, you can give me a thumbs up so you can see what is happening now. Actually, this is not what is in the .exe, okay, yeah, but this is a situation where, because we tasked Notepad to open the file, it is trying to make sense out of it. Okay, and remember, what is contained in that executable is the machine language equivalent of the source code we wrote, and Notepad is not meant to read or to understand that. So it is trying its best to, you know, make sense out of the content we've asked it to open. Yeah, and this is what it gives us. So yeah, you get a point. Okay, so now let's take a look at what each word here, each line of code here is doing. First of all, let's start with the hash include Iostream and using namespace std. These two lines are collectively called directives. But then the first line, line 1, which is the hash include Iostream, is specifically called Preprocessor Directive, and using namespace is called the using directive. The preprocessor directive here is not a program statement. Now, what do I mean by this? When we write program statements like what we have here, it instructs the computer to do something. However, this line of code here is rather passing information to the compiler, or it is instructing the compiler to perform a task. And the task is that it is telling the compiler that, hey, we need this library available in our source code. This library contains codes that makes it possible to write to the screen and also read from the keyboard and all this thing. So because we want to print something to the screen, we actually need to make this library available in our source code. So this line of code here, which we call the preprocessor directive, all it is doing is instructing the compiler to make available this particular library so that our program can use it. So the rule of thumb is in C++, every statement ends with a semicolon. So you can see that we don't put semicolons on the preprocessor directive. A part of the compiler called the preprocessor is responsible for processing these preprocessor directives. Okay, before the actual compilation process, the preprocessor is invoked to execute. So the first task that the compiler does is to invoke the preprocessor directive. So in essence, the preprocessor directive information here tells the compiler to insert this file here into our source file. Adding this Iostream file to our program makes it possible to perform input and output operations without the need to write our own code. The Iostream library contains declarations that are needed for this cout and endl that we are using here. If we don't bring in this, the compiler will not execute it. So if you like, I can take this out and let's see the response. If we try to run, boom, we have an error that says that cout was not declared in this scope, endl was not declared in this scope, system was not declared in this scope. This is because all these definitions are associated one way or the other with the Iostream library. Okay, now in some compilers you would actually see something like sometimes you can see something like, instead of the angled bracket, you see something like studio.h. Okay, now if you see this, don't be alarmed. Don't be alarmed. Modern C++ header files don't have extension. However, the older header files have the .h, so when you see this, don't worry. So far as it works, everything is fine. Now let's talk about using namespace STD. In C++, a program can be divided into different namespaces. Take a namespace as a part of the program in which certain names are recognized. Outside of this namespace, they are unknown. Now, usually the example or the analogy I give is, take yourself for example. There are a circle of friends or group of people, or there is an environment within which you are known. Outside of that environment, nobody knows you. So that environment within which you are known is your namespace. So in effect, using namespace std here says that all program statements that follow are within the standard namespace. That is the meaning of the std, standard. Again, various program components are declared within this namespace. Components such as cout, nline, etc. Now, if you don't add this global directive, then again, the compiler would fail to see, even though we have the Iostream library over here. So let's take this one to out and see. If I try to compile, we get the same error. It says that cout was not declared in this code, because one way or the other, we need to make sure this is available before cout can work. Okay, but then there is another way of doing this. Instead of putting it in a global declaration, I can use the scope resolution operator on this like that, and this should also work just as the previous one. However, just imagine if you are supposed to type thousands of cout and cl, or use many things from this Iostream libraries or the std namespace, then you would have to be doing these things every time. No, it is boring. So we write it once and forget about it all. Okay, so all that we have to do is to make this declaration appear, and when we put this declaration up here, we have kind of declared it in a global scope. So take it as now, instead of you being known by a circle of people within just an environment, you are uplifted and the whole world now knows you. Good. The next line of code is int main. Int main is called a function. Now, functions are fundamental building blocks of most programming languages, C++ included. Now, our HelloWorld program consists of only one function at the moment, which is the main. If you look at the program, you realize that it's only the two directives that are not part of the program. And again, remember that I said the directives are not instructions for the computer, but for the compiler. Every aspect of the program must be directly or indirectly linked to this function main before it can be executed. A function has four main parts. We have the return type. In this case, it is int. Then we have the name of the function or the identifier. Then we have the set of arguments which comes in between these parentheses, but for the case of this program, we have an empty set of argument, and the function's body. Okay, so the function's body is enclosed or is delimited by the opening and closing braces. Now, in Java, you hear of something like function signature or method signature. So if we bring the same concept here, then the method signature is made up of the return type, the name, and the set of argument. But in C++, you are most likely to hear about prototypes. Okay, so when we get to that point, I will explain it better. The return type of the function, in our case, int, which represents an integer, means that when the main function is done executing, it would return an integer. The return type of a function, talks about the data it will return, the type of data it will return when it is done executed. So if you look down here, we have return 0, and when I run this program, you see process exited after 1.246 seconds with a return value of 0. Usually on unit systems, this return value is used by administrators to know whether the program successfully or naturally ended or there was an error. So if I change this value to, let's say, return 100, then that is what I'm going to see. It's going to say and return value of 100. So when you are writing codes, you can use this return values to kind of give feedback to the operating system. So let's say I can put this exit statement here and put 100 here. Now when the program comes across this exit, it means that it should terminate the execution. Now let's run this and see. And you see that we don't have the hello world anymore. Now process exited after so and so seconds and the return value is 100. So now as a system administrator or as a developer, when I get complaints about my program or my application misbehaving, I can go in and query these values and know which side of the code is misbehaving. And of course, that means that you have to properly set a format for these things to work well. Okay, so let's take the exit out and come back. So that is the use of the return statement. Okay, so whatever value, the type of value that it will return is dependent on the data type or the return type of the function. Now some compilers will allow you to put void over here. In that case, you will not see any return statement, or even if there is a return statement, it's going to have no value. But the compiler that we are using here, requires it to have an integer return. Actually, I haven't tried returning something else. Let me do something else and see whether it will work. So let's see. So you can see here, main must return int. Is that okay? So the compiler requires that our function main must always return int. Now take note that there are many C++ compilers, so you just have to code according to the requirement of the compiler you are using. Main, over here, the word main in this case is the function's name or its identifier, which is how we choose to call our function. Now in the case of the main function, the name is main and it is case sensitive. So if I change it to capital M, that will be to a totally different thing altogether. A function also has what we call a set of arguments, which is enclosed in this parenthesis. But like I said initially, in this case we don't have any set of arguments, so we have no values within here. But as time goes on, or for instance over here, this system line of code or statement is also a function, and you can see that it is taking an argument, which is pos. Okay, so this is what we mean by an argument. So for our main, we don't have any set of argument. That is why it is empty. Lastly, the function also has a body, and like I said, the body is everything that is enclosed by these curly braces. In some programming languages, you see begin and end. Now, anytime you want to surround or delimit a block of program statement, you can use the braces. You can also deliberately create nested scopes within the braces. Now, I will explain this into details in later episodes. The main function serves as the starting point of execution for every C++ program. It is the function called when you run the compiled application. As a matter of fact, that is the only function executed by the computer. Now, when you run the program, the computer begins its execution from the opening braces of the main function to the closing braces. Therefore, any other function defined anywhere in your application must be directly or indirectly linked to this main function for it to be executed. So you can have one function calling another function, and that is what I call indirect link. Cout and return statements are called program statements, and they form the fundamental unit of C++ programming. The cout statement tells the computer to display the code, this hello world, on the screen. The semicolon at the end of this statement tells the compiler that, hey, this is the end of this statement. This makes it possible to stack many statements on the same line. So I can actually put another cout statement here, and everything should be fine. Okay, so far as there is a semicolon at the end, everything should be fine. Omitting the semicolon will trigger a compiler error. So whenever you get errors, try looking out for omitted semicolons too. Semicolons play same role as full stop in English, if that helps. So if we try to delete this semicolon, then we are going to get a compiler error telling us that expected semicolon before return. And you see, the IDE is quite smart to help you know exactly what is going on. The end of a line is not so important to the compiler. In fact, you can insert spaces and line breaks at certain places in your code to make it look beautiful for readability purpose, and the compiler will not mind. Look at this. For instance, I can put any number of spaces between that. In fact, the compiler actually doesn't mind, okay, because to the compiler these things don't even exist. They are invisible to the compiler. But remember, your source code is for the human reader, not the computer. So the rule of thumb is, if your code's readability is not appealing to yourself, then make it better. But hey, relativity, so what you like may not be what others like. So please follow the conventions used by the C++ community so that other programmers will find it easy to read through your source code. Personally, if you show me an improperly formatted code, I feel reluctant to even go through. So chances are that others do too. Now let's make this clear. There are exceptions to these white space rules. Preprocessor directives, for instance, must always be written on separate lines. Now let me try to include another preprocessor directive here, CSTD library, and see what happens. Oh, okay, it runs but with warning, and the warning says that extra tokens at the end of #include directive. Okay, so yeah, it didn't signal an error, but there is a warning, so it is not something you would like to do. Now you realize that if I move this down, we shouldn't have that warning. Yeah, and we don't have it. Okay, so always try as much as possible not to stick preprocessor directives on the same line. Now when we run the program, you realize that the only part of the program or the code that we see is the hello world, right? Yeah. This is because we instructed the computer to print this to screen, and cout here is the object used for doing that. It displays everything in this code, that in this hello world text on the screen. Now when we put things in quote, then we are essentially telling the computer that, hey, do this as it is. Okay, it is like reporting what someone said in English language. You can do it in two ways, either by paraphrasing, trying to use different words to express the same thing that the person said, or repeat exactly what the person said. Now in the latter, what you have to do is put the speech in quotes, and you are done. Okay, The identifier cout, which is pronounced cout, is an object. In programming, when we talk about an object, it is nothing but an instance of a class. We shall look at classes in later episodes. Now, cout is predefined in C++ to correspond to our standard output stream, and in this case, that's our computer's monitor or the screen. A stream in programming is an abstraction or a concept that refers to the flow of data. Okay, so the standard output stream normally flows from the primary output device, which is the monitor. However, we can also redirect our output to other output devices and even files. The double less than operator, as we have in here, is called the insertion operator, or other people also refer to it as the put operator. Now, its job is to direct the content here, in this case hello world, into this object for it to perform the task of displaying it on the screen. Now, there is another sign that goes the opposite direction, which is called the extraction operator. Now, this extraction operator is used with cin, which we will look at in the next episode. Cin is used when we read stuff from the keyboard. Usually what I've noticed is that for newbies, you see them confusing this with that. So the trick that I always teach them is to imagine a funnel. So cout here is a container, and we want to pour some information, which is hello world, into cout. Okay, but then we have to do it with the help of a funnel. Okay, so if you look at this, you can see that this is the tip of the funnel, this is the opening of it. So always the tip should point to the container, in this case our cout, and the opening should point towards our source of data, in this case our hello world. When writing code, it is good to insert what we call comments. Comments help you and anyone who must read your source code to understand what is going on. Now, comments are like white spaces to the compiler. In fact, they do not add up to the size of your executable program, neither do they even add up to your execution time. There are two types of comments. So what we have in here are examples of comment. Now, there are two types of comment. This particular one, which spans just one line, is called an inline comment, and we have this that spans multiple lines. We call it multi-line comments. Now, inline comments are created using double forward slashes. Multi-line comments are created using a forward slash and asterisk, and it is closed with an asterisk and a forward slash. With inline comments, you can even insert comments at the end of statement, but you can see that you can't do same with this guy here. And also there is nothing like nesting comment. Once I create a comment block, anything I put in there is seen as a comment. So you can't put one comment in another. It doesn't change anything. So the rule of thumb is use multi-line comment when the comment has to span more than one line. Use inline comment when the comment has to span just one line, or you want to put comment at the end of a line of code. It is generally a good practice to write comments. However, try as much as possible to avoid unnecessary comments. They tend to be a nuisance. Alright, I hope this helps. If you are interested in learning electronics, then check out my Electronics 101 tutorials on this same channel. Now, if you like the videos, then please don't forget to like and subscribe. Thank you for watching, and see you in the next episode. Once again, I am Prof, and this is Tech Foundation.